Well, greetings out there in YouTube land. I hope all is going well with you. I've got a kind of what I think will be a fun video planned for you, and it's going to involve the restoration of this ancient beast that one of my customers showed up with. I think he bought this on eBay, and it's a 1938 or 39 Rickenbacher Model 59 student amp that was sold by Rickenbacher for use with their lap steel guitar. It has a metal cabinet, which makes it dangerous as heck if it's not properly grounded. And I'm going to take you through all my steps that I do on an old amp like this, both the research that I do on it, and then the circuit analysis, the repair, checking it to make sure it's safe, all the steps that I think are necessary to carefully and properly restore an ancient piece of electronic history like this. Granted, this isn't a classic Fender Tweed amp, but I'll tell you, these old ones really get me excited. I just love working on them, okay? They're so primitive and so neat. And if you feel like I do, and if you don't, I guess you shouldn't be watching, then pull up an easy chair, grab some popcorn, and get ready to watch this thing as it progresses. Well, the cabinet's simplicity itself, it's just stamped out steel. The leather handle is long gone from the top. And then for a speaker grill, they just drilled an interesting pattern of holes in the metal front. It's painted sort of a grayish cream color with a airbrush black perimeter. And as we'll see, that's exactly what the steel guitar looks like that it goes with. Now the rear of it's kind of interesting. They did a reverse pattern, like a negative here, with instead of dark perimeter, light center, they went the opposite on the rear of the chassis. If you notice, we've got an electrodynamic speaker here, probably, what is that, 7 inches in diameter. I'm going to take it out and measure it. We've got our output transformer attached to the top of the basket, as they loved to do in the old days. Massive power transformer. And then a 5Z4 rectifier, 2 6V6 output tubes, back here are the glass tubes, and then a 6SJ7 preamp tube. Now if you're wondering like I am, where is the phase inverter in this? I don't know. And also I can't find a schematic for this. So I'm going to have to take it apart and actually draw a schematic for it. Once I've done that, I'll discuss it with you and we'll see how this circuit works. Also, somebody at some time or other has replaced the power cord with an equally wretched vinyl covered two-prong plug, which when you've got a metal amp cabinet like this, you just don't get away with ungrounded cords. Okay? I mean, I'm all for originality, but this is just not going to work. So one of the first steps will be to put in a grounded 3-wire cord. And then talk about simplicity. This jewel has no on-off switch, no volume control, and no tone control. Okay, they went Leo Fender one better than he did on the Champ, and they just eliminated everything. I guess when it's time to play the steel guitar, you just plug in the cord and hope to God you got it in the right orientation so that you don't get electrocuted, and then just start strumming away. I shudder to think of the difficulty you'd have nowadays marketing an amp like this that is a shock hazard and has absolutely none of the bare necessities normally associated with guitar amps. I still love it though, so let's start taking it apart, let's check out its history, and let's get started on the restoration. Okay, let's do a little research on the Rickenbacher Model 59 Lap Steel Amplifier and matching lap steel guitar, which is also Model 59. You notice that they have exactly the same paint scheme, which is best for fashion-conscious lap steel guitar players. They show the rear of the cabinet, which looks just like the one we have out in the workshop with the kind of reverse painted panel here, which is odd, but everything else looks exactly right with the output transformer, the right speaker, big power transformer. Everything looks good, which is a great touch. The tubes in this case are all metal bodied, which are older. Obviously the one in the garage has had the 6V6s replaced. Here's a close-up of the amp, and there's the leather handle that will guide me to try to either make or buy an appropriate leather handle for it, and some more pictures of the detail shots here of the steel guitar it goes with. Okay, next step is going to be to dissect it and to draw up a schematic so that we can start to understand how it works. Okay, and just one thing before we continue, let's have a little pop quiz. What do you think is the best way to proceed here? Just grab our fire insurance in one hand and plug this jewel in and hope it works? Or maybe to do a little internal analysis first, check it out before we proceed. Okay, now no cheating on this test. Okay, let's take a look at the tubes that came in the amp. I think it's important to remember these may not be the right tubes for this amp. Just because they're in it doesn't mean they're correct. First we see a 5Z4. This is a full wave rectifier tube, and one with which I have no experience. I have never seen one of these before. Next we go to a 6SJ7. Now this appears to be in the preamp position. Now it's a pentode tube, and therefore if this is a pentode and we have two 6V6s, you start to wonder if these are in push-pull, where is the phase inverter? Perhaps they are in parallel. If this were like a 6SL7, which had two triodes within it, perhaps the first triode was the preamp, the second triode might be the phase inverter, but it's not. This is simply a pentode tube. I don't really understand how this circuit's going to work. We'll have to wait and see. And lastly come the later 6V6s. These are glass tubes. These are not obviously the ones that came in the amp. Hopefully they're good, and if they work, that's just peachy. We're going to have to check out though to see how they're wired. Are they in parallel or push-pull mode? So that will come once we dissect this beast and start to evaluate the circuit. Okay, I removed the two screws holding the chassis in place, and I always love it when you get this type of beautifully matched screw set. I have a feeling this one's probably original, and I also have a feeling this one isn't. Okay, we got the chassis out. Let's take our first look inside. First, what dominates this is a large filter choke, which really makes no sense because with the electrodynamic speaker, the field coil, which is down here, is usually the filter choke. So we have this filter choke and this filter choke, which is even more impressive in an amplifier that has no on-off switch or volume control. Okay, once again, we're going to have to trace the circuit and figure out what's going on here. Next, it's like a rogues gallery of big old leaky capacitors. Look down here at this one. Look at that, leaking out the end. We've got spider eggs. This is just an adventure in electronics here. One last thing before I start trying to draw up this circuit. In amidst here all the old leaky, waxy capacitors, we have these really choice-looking ancient resistors. And if you're wondering where the color code system started on resistors, this is where it came from, okay? It's body and dots. So it's red, green, yellow. Okay, then they just changed on more modern resistors to make them bands. Okay, I'm working here on this yellow Aerovox electrolytic, and look at this. You talk about dried out and worthless. Just hideous. But over here is where the laughs really begin. It's got two leads that come out. Okay, I cut the one that goes down to pin 5 of the rectifier, but the other one is just wrapped around this capacitor lead. So I guess they wanted to use a dual capacitor so they could use one lead for the circuit and one to wrap around something nearby, like an octopus holding on to a seaweed or something. Real space age technology here. Okay, for a little comic relief, let's see what the ESR meter thinks of this wonderful Aerovox. It doesn't even recognize it as being a capacitor. Now, Next step on the comic cavalcade here, we're going to hook up the mighty Aerovox to an ohm meter. And as you can see, it's actually taking a charge. Okay, and it's not dead shorted. And if this, one of the worst capacitors I've ever laid eyes on, is not dead shorted and still takes a charge, it gives you an idea just how resilient electrolytic capacitors really are. Okay, now I'm down here removing that big old orange Mallory electrolytic, and I was going to unsolder the end that hopefully was grounded. Look at the solder joint that was done, and this nice piece of wire sticking out, guaranteed to short something. Sweet work, huh? Are you starting to see why I say don't just plug them in? On these really ancient ones like this, you just have to go in there and see what foolishness has been done and undo it. Now on the orange Mallory, it still reads 34 microfarads, and the ESR value for a 30 microfarad capacitor is really not all that bad. I still don't trust it. I'm going to replace it. Okay, let's discuss the circuit. Like I said, I could not find a schematic for this anywhere, so I just had to analyze the circuit and draw up my own schematic. As you can see down here, we have the 5Z4 rectifier, and the old filter capacitors were something like 16, 30, and 8, but I put in 22, 10, and 10, all at 450 volts. These two are on either side of the filter choke, and these two are on either side of the speaker field. The nice smooth B plus now comes up here, goes to the center tap of the output transformer, and is fed to the plates of the 6V6s and also to the screens of the 6V6s. The tubes, the output tubes, are cathode biased with a 225 ohm, about a 10 watt resistor mounted against the chassis wall to dissipate heat. Now we'll address the phase inversion portion of the circuit, and recall that there was a 6SJ7 in this place, which made no sense to me. Well, it was the wrong tube, and when I drew the circuit, it became evident based on the connections and what the connections required that it had to be a 6N7 tube. As you can see, the 6N7 has a common cathode that is cathode biased with about a 5K resistor to ground. Now here's the signal. Notice that the signal's up, down. It's going to be fed in over here to this grid, the first grid of the 6N7, and then output from the plate. And as you recall from the phase inversion video, the plate inverts the signal that's on the grid. So we now have a down-up signal. It leaves, comes here, and goes over to the grid of the upper 6V6. But a portion of it, after the coupling capacitor comes down through here, still inverted, feeds into the grid of the second half of the 6N7, gets inverted, and comes out the plate, so that now it is inverted with respect to the other plate's output signal. So we have phase inversion. This one then is fed in here to the grid of the lower 6V6. The only other thing to notice here is the B plus comes up and it's fed through the 100K plate resistors to the plates of the 6N7. Not much else to report. 0.05 microfarad. These are those waxy capacitors that were inside over there by the input section. 0.05 microfarads, and I left them in. And I think, as you'll see, they sound pretty good. Okay, so that's the circuit. I think it's interesting to see just how similar this phase inversion and output circuit is to the Gibson EH150. 6N7 feeding to, in this case, 6L6s, not 6V6s, but other than a few resistor values, it's absolutely identical. We talk about different types of phase inverter, and in this case, I can see elements of both a long tail pair because the cathodes are linked in the 6 and 7. And I can also see elements of a paraphase phase inverter because the output from this plate is fed back into the grid of the second stage, and there is a grid leak to ground to reduce the signal just a bit so that when it is amplified again, it's about the same amplitude as the original signal that was fed into it. So I don't think this one's all that cut and dried. I think there's an argument to be made for either type of phase inverter. Well, let's take a look at the circuit and see how it turned out. You see here the three new filter capacitors. The old ones were of all strange values. I went with a 22, 10, and 10. Over here is the 3-wire grounded cord, and I grounded it to one of the bolts that holds the transformer and the filter choke in place. I'm going to leave the 0.05 microfarad coupling capacitors in place even though they're waxy and old, just to see if they still work. Back here is the cathode biasing resistor, 225 ohms for the two 6V6s. Okay, the time has come to test the power supply. I'm going to plug it in back here to the current limiter, and we'll see what happens. If the bulb flashes real bright, then I will immediately disconnect it. If it doesn't flash real bright, then we'll watch over here as the B plus comes up on the plates of the 6V6s. Now, there are no tubes in it other than the rectifier tube, so the plate voltages will be rather high, but we're going to see if those plate voltages are present at the pins. Okay, here goes. All right, no flash of light. Now watch over here, and we can expect to see, there it goes, 484 volts to the plates of the 6V6s when the 6V6s are in place in the sockets. So it appears the power supply is functional. Now that I've unplugged it, watch over here as the B plus dissipates from the filter capacitors. Even now, it's about 20 seconds since I unplugged it. There's still 400 volts in here to shock the heck out of you if you're not careful. Now, this is why after you have turned off and unplugged an amp, there's still a risk because there's still a lot of voltage in these filter capacitors. Because the tubes are not present, it drains much more slowly, but still you have to be careful, even if the tubes are present, to drain the filter capacitors before you touch any part of this circuit. Now, instead of the 6SJ7, which was incorrectly put into the tube socket of this amp, I have a proper 6N7. This is a really snazzy looking old one. Unfortunately, it tends to be microphonic. It's a tube I keep just for test purposes, and it'll have to be replaced, of course, with a NOS 6N7. But for now, it should at least tell us if this amp circuit is going to work. Since shorts can exist in tubes, which can really jeopardize your components, especially in an old irreplaceable amp like this, I'm going to test the 6V6s here on my Hickok Model 600A tube tester. Over here, if there's a short, this light will come on and stay on. So you flip it to all the different positions and there's no short. Then we push on number 4. Watch the needle. It rises up to the, it's sort of a marginal tube. You would like it to sweep much further. A tube with more emission would deflect the needle further. But there's no shorts and it has reasonable output. Okay, let's test the second tube. No light, no shorts. Push number 4. We see it's about the same as the other tube. Marginal, it's still usable, but not a great tube. Just for fun, let me show you what a shorted tube looks like. See that? In this case, this tube has a dead short between the screen and the grid. Okay, now the acid test. The tubes are in it. I'm going to plug it into the current limiter. We're going to keep an eye on the bulb, make sure it doesn't start to glow. And over here we'll see the B plus start up here on the plates of the 6V6s, running around, what, 280 volts. Amp is very quiet. There's a very slight hum. Let's see if it's working. I'm going to touch the input. Complete success. Okay, one last safety test before I plug in a guitar to see how this amp sounds. I'm going to run one end of my voltmeter from a known ground over to the chassis to see if there's any potential between this chassis and ground when the amplifier is plugged in and operating. I've got my voltmeter here to AC volts. Why it's showing 4.37 with nothing plugged in, I do not know. But here we go. I'm going to plug it in, and it goes immediately to 0. So there's absolutely no potential between the chassis and ground, and so touching this metal chassis or this metal cabinet will not be hazardous. Obviously the 3-wire grounded cord is working. Okay, here we go. I'm going to plug in the amp into the current limiter. I've got the guitar plugged in up here to the input jack. We'll give it a second or two to warm up. I've got the guitar at like about 5, say mid-range volume output. Not too shabby. Okay, just for laughs, I've cranked the guitar all the way up to 10. Okay, these are humbuckers. We'll get a pretty good output signal. Remember that this amp does not have a preamp stage, so let's see what we get out of it. Wow, I'm really impressed. You know, it has really good bass response for a small open back speaker like this, and I've done nothing to the speaker cone. I probably will, but for now I think it sounds about 10 times better than I ever dreamed. I hope you think so too. Well, here's the finished product with its 3-wire cord, and I made up a little black leather handle for it. Here's a detail of the handle. I just cut it out of a piece of leather, but looks sort of like the original, and I think the black goes well with the cabinet. The inside looks about the same as it did, except there's the addition of the 6N7 phase inverter. Speaker cone checked out. It had a few tears that had been repaired in the past, but all in all it seemed like it was in fine shape. So that's about it on this video. I hope you enjoyed watching as this 75-year-old amp was brought back to life, and I hope that you'll stay tuned for future videos. Thanks so much for your time and interest.